Hey, welcome to my correct mistake video. So today we're going to be talking about the periodic trend and electronegativity video. And for the first step is that first question: which element is most metallic in character? Explain reasoning. So an element being metallic or not depends on how electronegative it is. So therefore, the less electronegative it is going to be the more metallic. And the way we figure that out, because all we have is ionization energy. And the way we're going to figure it out is to look at the lowest first ionization energy. Because what happens is that across the period, ionization energy will increase, so therefore the lowest ionization energy will be the element that has or the element that will be the most metallic. So in this case, it's going to be element 2 is the lowest initial. For B, identify element 3, explain your reasoning. So the one I picked for element 3 was going to be element 3, which is second lowest. What's going to be magnesium, because what happens is that after you move the first couple of electrons, then you have 10 electrons remaining, right? And then you have a neon, and then once you remove the first electron of that orbital, it's like really stable, but it takes a lot of energy to move that electron. So what happened there is that there's a huge jump in ionization energy. You can see from element 3 it goes from 700 multiplied by 2 and then multiplied by 5, 6. By times 6, and then you get like 7,700 kilojoules. So this is because it's such a huge cost to removing the first electron in the stable orbital. And for C, I wrote it because what happens is that in the first or s orbital, second s orbital all filled, and then the second p orbital filled, and then the third s orbital all filled. Therefore, it doesn't go. Even though the third s orbital all filled, then it's going to take a bit of small bump removing the energy, but it's not going to be as stable as like the 2 orbital, if that makes sense, because if it was like 3p6 as well, then it'll be a lot higher, but then since it's only 3s, it's only going to be like 700 kilojoules per mole. And the third question was the expected oxidation state for the most common ion of element 2, and what is the chemical symbol for the element 2. So those questions kind of go hand in hand. You can answer one before the other, but I said it was sodium, because what happens is that if you look at the question, there's also a large jump from 496 to 4,000. That's times 10 or times 9, and that's a huge jump. And then also, there's kind of a larger jump after that, but it's not as huge. It's just like maybe comparable to like what a third ionization energy should be. But since it's a huge jump, I assume that also we're going to break that, not the oscillator world, we're going to break the stable orbital. So it'll be one right before will be magnesium, which would be sodium. So then group 1 metals usually have a +1 charge because they only have 1 electron, while the group 2 metal will have a +2 charge. So the most common ion, which would be fall under usually, it would have a +1 charge for the oxidation state. +1 for the oxidation. I don't know why I say charge. And then for the final question, and then the element symbol, as we said, was sodium. And then for the final question, I got that one right. Neutral atom, which of the 4 elements has the smallest radius? That's going to be the one with the, that's probably going to be element 4, because what's going to happen is that it has the highest, kind of has like the lowest, the highest ionization energy, which means it'll be furthest to the right, and due to the periodic trend, that means the atom's going to shrink the most, which means they'll have a smallest radius. So then element 1, which has the highest ionization energy, will have the lowest smallest radius. Alright, so thank you for watching.